I'm James Reeves. I've worked on a few projects like Ring, Composure, Hiccup. I'm currently a freelancer doing Clojure contracting work. And this is a practical tour of Clojure web development. So this is actually my second talk. In my first talk, I talked about, at the very sort of low level, how Ring and Composure actually work. And what I'd like to do now is take a little bit of a step back and look at the architecture behind developing a web application. So I'd like you to pretend that there is no social media, there's no Facebook, no Reddit. So we're in a parallel world where none of this exists. And we want to build a social news site. So pretend this is all new and that this hasn't been done before. So to this end, let's actually start with MVCORM, because that's kind of like the go-to architecture for the web today. If you're going to design a website, a lot of the frameworks you see, like Django or Ruby on Rails, have this MVCORM model. So MVC is ModelViewController, and ORM is Object Relational Mapping. So we'll start off with ModelViewController, slightly out of order there, but that's because the kind of order in which a user accesses the system is the controller acts as the go-to point. So a user will send a request to the controller. The controller will then go up to the model layer. The model layer represents the database, the actual data which you're going to present to the user. The view is how you're presenting that data. And then the view is passed back to the controller and sent back to the user. So let's take a look at what model we'd have for a social news site. So we're going to start off with a model, because when developing an application, it's a good idea to start off with the data first. So we want users, because this is a social site. We want to have some users here. We want to have some way of representing a single user. And users can post things, otherwise it wouldn't be a sort of social site. It's true for like Facebook or Reddit or Hacker News or whatever. And we want to be able to comment on these posts, because that's kind of what, I can't think of a single sort of social thing where you actually can't comment on things. And comments are both related to the users and they're related to the posts. So you've kind of got these two, it both belongs to a user and it belongs to a particular post. And usually we have this concept of karma, or voting, where you can vote on a post or a comment, and a user, so a user can vote on a post or a comment through this kind of karma system. So this is kind of our relational sort of diagram. We've kind of got these four concepts, and we've got these arrows going between them which describe their relationships. And as Clojure programmers, we kind of look at this and we sort of say, well, is this complex? So we kind of look at this previous diagram. So as Clojure programmers, we know that complexity means something that's interconnected or braided together. So Rich Hickey's talk, Simple Made Easy, goes into detail about this. And when we actually look at this previous slide here, there is a lot of interconnections going on. We've only got 4 components here, but every component is kind of related to each other. So even though each of these connections seems very logical, so karma has got to be related to the user, and karma has got to be related to a post or a comment. Comments have got to be related to posts, and comments have got to be by a certain user. So all these relations are very logical, but when we actually step back and look at this diagram, it's actually, there's a lot of interconnections here, and we might sort of start to think, well, maybe this is starting to look a little bit complex. So is it complex? Well, maybe. Could we make it simpler? Well, let's see. So in Ruby on Rails, we'd kind of have a thing like this. We'd create our model as objects, as classes. So in this case, you have a post, and in Ruby on Rails, you can say, well, a post has many comments. And then you have this thing down at the bottom here, where you can find a post by its ID, and you can call a method comments, which will give you the actual comments. So first question is, so this is what we kind of have, and this is kind of the standard, or the sort of de facto standard for developing web applications. And when starting to design an application in Clojure, let's use this as a basis. So rather than starting from scratch, let's kind of look at how we'd design something similar in Clojure and see if that makes sense for the language. So this is kind of like the equivalent code. In here, we have post find ID comments. Here, we kind of have it backwards because we're using prefix notation. But we have a function here, find post by ID, and then a function comments, which finds the comments for that particular post. So, okay, well, fair enough. We've got two functions instead of objects. But what namespace are these functions in? So in the Ruby example we saw back here, both find and comments are in the post class. So they're sort of elements of the post class. So in Clojure, maybe we want to put both of these in a namespace called posts. But this doesn't look quite right, because we've got a namespace called posts, and we've got a function in that namespace called comments, which is returning comments. And that kind of seems a bit odd, because we'd expect the post namespace to be all about posts. We don't expect it to be about comments as well. So this kind of seems a little bit sort of strange, and it might kind of send our coder sense tingling a little bit. So maybe we want to sort of change this and instead put it in the comments namespace. So we have a comments namespace, and we find comments by a particular post. And in the post namespace, we have this find method, which actually finds a particular post. So this kind of seems a little bit better, but do we need to grab the whole post in order to find the comments for that post? Well, actually, we probably just need the ID. So now we get something which looks maybe slightly more Clojure-y. We have a method or a function called, well, in the previous one it was by post. We can pare this down further by calling it by parent. So we're not looking for a post. We're looking for all comments which have the same parent. And maybe this is a post, or maybe it's another comment. So now we've kind of got a hierarchical view of this. So this divorces the idea of comments and posts. Instead of being strongly linked together, they're now a little bit more weakly linked. So instead of them being two objects which are very tightly connected, we now have a sort of fairly loose connection. And if we're going to have a rule of thumb for designing this, we're going to say, well, let's separate the application by data type. So if you want a place to start, and this is just a sort of loose rule of thumb, we can take a look at the data, the classes of data, the types of data we have in our system, and separate our application by data type. So put each namespace has a sort of different data type. We can kind of start there. Obviously, this won't be true in every single case, but it's kind of like a good start. And we want to do this because this makes the application less complex. It makes it less tangled together. We want to separate the application out as much as we can. So this kind of leads us to say, well, is ORM, is object relational mapping, is this a useful abstraction? Well, maybe it is for object-oriented languages, because in an object-oriented language, everything is based around objects. Maybe pulling stuff into objects makes it easier to manipulate. But in a functional language, it kind of becomes less useful, because we're not used, in a functional language, it isn't designed for manipulating objects, so we don't get that advantage. And ORMs have a few issues. So with ORM, you have no distinction between a value, something that's part of the data you're getting, and something which is a reference. So in our previous example, we had a post, and that post had comments. And that comment we know is a reference to another table. So the posts can be updated separately to the comments. But from a purely syntactic point of view, there's nothing in the syntax to distinguish between a part of the post and a part of the comments. So ORM presents this facade to us that everything is a local object, that everything is just this single value. And there's no distinction between what is a value, what is something that's actually connected all together, and what's just a reference, something that might change. And we know that, for instance, if you have a comment, the comment doesn't contain the whole user. It just contains a reference to the user. So that if you change so if the user goes in and the user changes their profile or changes their email address, that's not going to sever the connection between the user and the comment. So we know that when we talk about the author of a comment or the author of a post, we're talking about a reference and not an actual value. And because of this, we also have this issue that it's complex design. It has these strong ties between objects. In the Ruby on Rails example, we have a post that returns a list of comments. So the post class is actually returning comment objects, which means that they both need to be in the same application. We can't separate it out by process. We're tying these two things very tightly together. So is this the only problem with MVC? Is ORM our only concern? So if we maybe if we discard the idea of ORM, maybe the MVC, the ModelViewController, is still a useful abstraction to have. And MVC has its own problems as well, in that we have this three-layer system. So we have the model and view and the controller. But as the application gets larger, we don't add more layers. We just kind of scale these layers out horizontally. So we're not adding any sort of new components to the system. We're just kind of infinitely pulling out these model view controllers into a larger and larger blocks until the whole edifice collapses. And when designing large systems, or indeed designing any systems at all, you really want to separate things out into building blocks which are discrete and don't expand that much. If you want to expand the system, you want to add more building blocks. You don't want to stretch out the building blocks you have already. So maybe a better way of designing the system is to split it up by data type. So instead of having this model view controller layer, you have, in this case, 4 layers, 1 for each data type. And if you remember the previous example, we had it going in a kind of loop. So whenever a user accesses the system, they're always going to go through the controller, and they're always going to go through the model layer, and they're always going to go through the view. Maybe instead of that, we want to have this idea that if a user wants to get something about other users, then they're just accessing this one component. Or they're just accessing posts. Or they're just accessing karma. Or they're just accessing comments. So, okay, maybe that's a good way of doing things. But is this the best we can do? We've got our comments. We're checking, we're trying to find all the comments which have a certain parent, and we're giving them a post ID, the identifier of the post. But what exactly is this? So what exactly is this post identifier? How are we identifying these posts? So we've imagined that this is our comment data structure here. We want to ask, well, we have a parent reference. What data structure is this actually going to be? How are we going to refer to a parent? So is it going to be a numerical ID? Well, maybe not, because you have this problem of conflicts. you'd have to maintain some atomic counter, which you'd increment. And maybe there are better ways of doing it. And one better way, or it's a longer way, is to have a UUID. So we know that if you have a UUID, it's going to be unique. We don't need to keep this atomic counter. And we could effectively have separate things. We know that the posts, we know that everything is going to have a unique ID then. So we know that we're not going to conflict and have a post with the same ID as a comment, because every UUID is completely unique. So in some ways this is useful. We have this uniqueness constraint. We no longer have to worry about uniqueness. But this doesn't actually give us much information. If you just see this, you have no idea whether this comment has a parent, which is a post, or another comment, or something else entirely. So maybe we go one step further and have this idea of a URN. So URN is a way of identifying a resource without giving away anything about its location. So in this case, we have a URN, and we're saying, okay, well, it's of type com example post sort of thing. So that's a kind of unique classification. And then we have some kind of unique identifier afterwards, which identifies the actual record. So it's kind of like class and then instance. And okay, so we can now see that the parent of this comment is actually a post. It's not another comment. So we have more information. But we still don't know where this post is unless we give the application some knowledge about the wider system. And we can avoid doing that if we make the parent a URL. So a URL both is unique. We know that we can't have two URLs which are the same, which point to different data slots. And we know that it gives us information about what the thing is. So in this case, it's a post. And we might be able to query the HTTP server and ask for things like the content type, so we can tell what content type it is. So we've got information about what the parent is. And we've also got its location. So even if we know nothing else about the system, we can actually hit the parent and say, where is this? So at this point, the comment system now needs to know nothing about the posts at all. And we get something like a comment system which is entirely divorced from anything else. It's almost like a comment system like Discuss, which you can attach to any page. So maybe this is ultimately what we want to end up with. We have, in the comments namespace, we have a function called byParent. So we're getting all the comments by parent. And we're passing in a URL, which means that the comment namespace no longer has to know anything about the posts or anything else about any other namespace. So then we have to ask, well, okay, this is okay, but what happens if URLs change? What happens if we're designing some internal system and we decide to move things around a little bit? So maybe the users are connected with some other piece of data and we want to pull them out into their own web service. So a previous company I worked for actually had this problem. They were building up a service-oriented architecture for the first time, and as they were working, they were finding that some of the services they built weren't quite right, and they needed to pull them apart and rearrange where the sort of models were. So they had this problem of URLs changing, and they said, okay, well, this is a legitimate problem we have, and we want some way of solving it. So they created a web service which you'd pass in a URN, so something without location, and then that would return the URL of the actual resource. So you'd have a URN which just described the post or just described the comment. And then you pass that into this centralized web service, and it would return to you a URL which you could then use to look up the web service. And this divorced the ideas of identity and location. And it meant that they could rearrange how their system worked without needing to change any internal data. So, okay, that seems like a that seems like a solution to that particular problem. That if you have URLs that change, how are you going to work around that in your system? But as a programmer, when I first heard about that, I was kind of thinking, well, this is replicating the idea of DNS a little bit, right? You're passing in a URM, which is effectively some kind of numeric identifier, which means nothing on its own. And then you return a URL, which actually tells you where things are. So this kind of didn't sit too well with me when I first heard about it. But at the same time, if you want to change URLs, I couldn't think of a better solution. But the trap was that the idea of changing URLs in the first place. So if we accept that URLs can't change, that they're permanent things, that when you've created them, they're completely immutable and we're not going to change them ever, then suddenly the problem becomes simpler. By adding a constraint, we've removed the need to have a separate service for connecting your ends to URLs. So the answer, or one answer is to build this web service where you connect your ends to URLs, and another answer is just don't change URLs. And that kind of seems like the simpler solution. And the previous problem goes away. Now, I've sort of mentioned this to a sort of few people who have been designing APIs, and their first sort of instinct is to go, sure, that sounds nice in theory. You know, cool URLs don't change. But in practice, how is that going to work? But we deal with immutable names all the time when we're designing libraries. So if we're designing a library and we've released version 1.0, we can't go in and change the names of things just because we don't like it. We have to sort of go through the process and maybe release the second version of the library. And if we keep releasing versions 1, 2, 3, 4, and each version is incompatible, people aren't going to use our library. So we already deal with this problem as library designers. And it kind of seems weird that we don't want to deal with this system when we're designing service APIs instead. And we actually have more tools to deal with this when we're designing a web service, because we have a redirect function. When you're writing a library, if you make a name of a function, for instance, you call it car instead of first, or CDR instead of rest, then you're kind of stuck with that convention for the rest of time, effectively, until you design a new language with different conventions. So when you're designing a RESTful sort of API, you have more control with redirects than you would do over libraries. So just don't change URLs. URLs don't need to be connected to a particular machine. They can be completely independent. If we say that this resource is always identified by this particular URL, then a lot of problems go away. And just by accepting this constraint, we've made the problem easier. So that's the other point I also want to make, in that carefully chosen constraints can make problems more tractable. They can make it easier. And as another example of this, there was a paper a while back called Software Transactional Memory. Why is it only a research tool? And in it, the authors described all the ways in which software transactional memory wouldn't work in a system with mutable variables. But we know in Clojure that STM works quite well. And after 4 or 5 years of actually using Clojure, we haven't actually come across any huge problems with the STM implementation in Clojure. So, and the difference between their paper and Clojure is that Clojure has immutable values. It doesn't have mutability by default. And this constraint of immutability made the problem of STM suddenly more tractable. It suddenly made it possible to do things. So if on the one hand we have this idea of simplicity, we want to make a program as simple as possible by removing connections. So we want to make sure that functions are written on a need-to-know basis. we're kind of like a spy agency, so we kind of want our assets to know as little as possible. But at the same time, we want to constrain them so that they also can do as little as possible. So we want to limit information flow around our application, and we also want to limit what functions can do by adding these constraints in. And sometimes even very broad constraints, which when you first think of them are very difficult to reconcile, can actually make your program a lot simpler. So when I first came across the idea of functional programming with immutable variables, and you didn't have loops, and you didn't have variables you could change in the middle, I was kind of a bit stuck as to how you do simple things like for loops or while loops or just iteration in general. And it was only when I started actually learning functional programming properly that it suddenly became clear that you didn't actually need those things, and that things you thought you needed, maybe you don't. So if you choose some constraints which kind of seem quite broad, maybe they're not as broad as you thought they were if you just look at the problem in a different way. So we've got a system where we've separated out these posts, these comments, and this karma into these separate silos. And these silos have no direct links between each other. They just have this idea of these URLs, these references. But how do we deal with composite data? So if we have, for instance, a front page of our social news site, and it requires posts and karma together. So this is a sort of idea of some posts, and they have some karma. And we know that social news sites are all about people reminiscing about the 90s and cats. So we want a front page with posts and karma together. But we've just said we're going to put posts and karma in their own separate silos. So given that we have these kind of siloed data structures, how are we going to then create a function which uses both data from the post namespace and data from the karma namespace? I mean, where would we put this function? I mean, do we put it on posts and then have a reference to karma? Or do we put it in karma and have a reference to posts? And then what do we do when we get a cyclical reference, where we have some functions in posts which rely on things in karma and some functions in karma which rely on posts? And maybe what we want to do is instead actually create an entirely new namespace. So we create an entirely new section of the program for posts and karma. And we can think of this as a pure function on the data we have already. So the post and the karma are things we can actually change. They're things we can update. There are mutable references. And posts and karma is a pure function, a view on the data we have already. So we have, in our namespaces, we have users, posts, comments, and karma, and we have posts plus karma as our new namespace. So as far as I can tell, plus is actually a valid character for namespaces. It seems to work, but if it isn't, then you could always say posts dash and dash karma. So we have this thing, and this is effectively just a pure view. And I've distinguished in this case where we have the data there, and now we have a view which actually doesn't change anything on its own, but it's just a way of viewing the data we have already. And maybe we're just designing this system, which is fairly small. We have a naive approach where we just have a function called front page posts, and it just runs some SQL which just happens to call both of these tables. And maybe this naive approach is good for a small system, or even for a medium-sized system, because SQL is pretty quick. We don't even need to go into a NoSQL all the time. But if we do, by siloing this off, we've sort of paved the way for scaling up if we need to. So let me just talk a little bit about scaling up in the time I've got left. So if we want to scale up posts and comments, the actual pieces of data we have, the things where which are modifiable, the resources which we can reach in and add stuff to, then this actually turns out to be pretty easy. We can put one on one cluster, one on another cluster, and because we separate them out by reference, they don't even need to use the same database. So this is actually quite easy. Posts and comments can use two different data structures, two different databases. Maybe they use some kind of NoSQL database like React or whatever, or SimpleDB or some kind of Amazon cluster. And if we're just dealing with this kind of set singular sort of data, if we have a resource, we're just going to dump it into a database somewhere, and we just want ways of searching for this, it's actually a fairly sort of simple problem. I'd say it was almost a solved problem that we have today. But how do we deal with composites? So how do we deal with the idea that we actually want this view of posts and comma? Because we can no longer just run a single SQL statement over both the tables, because now they're in two different databases. And assuming we're not using something like Datomic, which can handle two database joins, then how can we deal with this? So Nathan Mars had a talk called Runaway Complexity in Big Data and the Plan to Stop It, where he outlines a way of solving this problem. And in it, he says that you effectively just have a cached view. So because you can think of posts in comma as like a view, a pure function on the data we have already, we can have it as a background process or a cached background process. So every so often we have some machine for computing this view which grabs data from posts and comma. And we'd ideally want to do this through polling rather than push, because then the posts and comma don't need to know anything about the systems they're pushing to. They can just supply the data, and then we have this posts plus comma processing machine which goes in and polls the raw data every so often, maybe like once a second or something, for new data. So then the data is computed, and it's cached. And then when a user wants to actually access it, the user is just served from the cache itself. And for a lot of things, this works because you don't necessarily need a real-time view. You don't need to necessarily have everything up to date to the nearest millisecond. If you're just thinking about the front page, it maybe only needs to be updated once a second, or maybe even once a minute, or once every 5 minutes. You don't necessarily have to have this real-time idea. So aggressively caching views is a valid strategy which can work in a lot of circumstances, especially with sites which are not designed as real-time communication tools. Sites which display a bunch of messages or a bunch of news posts, and you don't necessarily want to have news posts popping up in real time to distract you. So once we have this idea of, okay, we have this external process, it goes in, it grabs these resources, it processes them in some way, and delivers a cache to the user, we have to ask, well, how exactly are we going to process this data? So one of the sort of obvious solutions is, okay, well, if we want to process batch data every 5 minutes or every so often, maybe we want to use a tool like Hadoop. So we split this system, we split the calculation across multiple machines, and we use Hadoop to the MapReduce architecture to work out the end result. If we want something more real time, well, there's Storm, which is also developed by Nathan Mars. But I kind of think there's a third thing on this list which I haven't discovered a solution to. And this is the part of the talk where I look a little bit into the future rather than describing what's already here. And I think the thing which is missing is a way of incrementally processing data. So if you have a cache of data already, and you have a list of changes which are applied to that cache, you should be able to efficiently calculate the new cached value just using that list of changes and the old cache. So is this a missing link? So I'll just show you more sort of what I mean. That if you have a function up at the top there, where given a cache and the data item, you get an updated cache, is there a function which, if you give it a sort of list of changes and the cache, that it will deliver you that updated cache? And in Clojure, that kind of function would be called a reduce. And I haven't noticed any generic processing tool which does this. There are processing tools, incremental sort of batch processing tools in CouchDB and in later issues of MongoDB. And they will compute a view incrementally, but they're bound to the databases directly. So the CouchDB incremental sort of processing system will only work with CouchDB, and the MongoDB thing will only work with MongoDB. And there doesn't seem to be any sort of general way of giving a pre-computed value and a list of changes, efficiently getting out a new value. And in Clojure, this should be called a reduce. So I kind of wonder whether this is a job for Clojure's reducers library, whether if in future we couldn't use the reducer system in Clojure 1.5 to somehow turn a large cached data structure into another large cached data structure given a list of changes. So if anybody knows of a tool like that, I'd be interested in hearing. If not, I'm going to sort of throw that out as a sort of general sort of challenge to something we might want in future. So that's the end of the talk. And I'll throw the floor open to questions.
Who's got questions?
Hi. Have you given any thought to instead of polling instead of the views polling the data or the data pushing, having a broadcast so the data can just publish to anyone who's interested?
Yeah. So one option is to write the resources and ways of using some kind of broadcast system like 0MQ, or I think there are some other ones which do similar jobs to that. PubSub, I think, does that. That's another option. It kind of strikes me as maybe more complex than a simple polling system. If you only want to poll your data every 5 minutes, then putting in some 0MQ or PubSub or something like that kind of adds additional complexity that you don't necessarily need. And this is all functionality which can potentially fail. So maybe keeping it as sort of straightforward as possible, even if it makes the system less efficient, it might make it more reliable.
Hi. So with that design, you had a cache for like a pair of objects, karma and posts, right? Yeah. Doesn't that mean that, like, as the system sort of evolves, you'd have one of those for every member of the power set, sort of thing? You know, like karma and posts, karma and comments, karma and users, like every pair and then every triple and every.
So you're saying that as the system expands, we just end up caching more and more data?
Yeah, and that the means by which you're caching it is like arbitrary subsets of your data types. Like you're pairing up arbitrary subsets and getting many, many instances of those. Yeah.
Well, caches don't necessarily have to be dumb. They can actually be fairly smart. So you could cache the data structure in a system which allows you to do some fairly sophisticated polling. It doesn't have to be like this static thing which you have. I think the main point is that the cache is something that's just a pure function over the data you have already. So in theory, you could throw away the entire cache and recompute it from the stored data you have available. And even if the cache is sort of fairly sophisticated, and you can search the data or do something which makes the cache quite small in practice, so long as you can throw it away, it's still a cache. Does that answer your question at all?
Not quite, but I'm not sure I can phrase it well enough to bore this many people with that.
Okay. Maybe we can talk about it afterwards.
The more entities you introduce into the system, the more possible interactions they have, and that original square that you had actually ends up more complicated because it's like comments plus karma plus users plus latest plus hot. You know, it just seems like it's a naive approach to aggregates. But I do think the aggregates approach on the base entities is correct. I just think what you kind of put forward is dangerous.
Well,
in a not in a landmine way or anything like that.
So if you took a naive approach to caching, that might be true, but caching doesn't necessarily have to be dumb. It can be fairly smart. So if you could represent your original system as a series of tables which are all connected together, then in theory you could represent your cache as the same thing.
So I think that's maybe a better way, is to say that you have the base entities that are raw, but then the aggregate data is itself data, and maybe it is persistent rather than cached.
It kind of depends on how much data you want to pull in. If you just have a set of posts and comments, then you could create a cache which effectively is two tables which you join between two things. Or you could have a less sophisticated approach where you just dump it all into S3, and each set of page of posts is it's just a static list of things. So I don't think there's one size fits all. I think in some cases you'll need some very sophisticated indexing in order to get performance right. But in other cases, you may need some very sort of dumb indexing. So you may just want a key value store instead. And I think this approach allows you to pick and choose. So long as you've got the base set of resources available, your cache can be as sophisticated or as dumb as you like, and can include the whole data, can include all of the resources, or preferably just a subset of them.
So kind of following on again with the S3 idea, are you composing it on the client side or the server side, do you think? Or does it matter?
Well, you'd probably be composing it on the server side. But effectively the server would be a client of the resources you have already, or a proxy of the resources you have already.
Right then, anybody else?
Just a quick comment on this last point. I think, I forget the name, but there's a famous computer scientist who stated that cache invalidation is just one of the hardest problems in computer science. So I don't know if there's an easy answer to it. I think some of these problems people have been mentioning are quite inherently tricky ones, and they've certainly ones I've had in the past, especially, as you're saying, when the data dependencies grow quite complex. You've just got to think very hard about how to break down those data dependencies and the way you consume the data and the kind of data flow around the system, I think.
Yes, so maybe I glossed over it a little bit. It's not an easy solution. In fact, maybe I've just pushed the complexity into the actual caching structure itself. Is sort of cache invalidation, but at least if you're sort of designing this way, you've pushed out part of the problem. So in the sort of classic MVC approach, you're sort of doing everything in sort of one section. At least this approach takes some of the complexity and pushes it out into different components.
One last question? No? Thank you very much, James Reeves.
Okay, thank you.